people who are visual learners, you can use an equation to create the graph of a line. So equations can be super important for problem solving, but before we can use them, we need to know how they work, right? So what you're seeing here is an example, is an equation showing the relationship between degrees Fahrenheit, right here, and degrees Celsius, right? So if I know the degrees Celsius, right here, then I can figure out what the same temperature is in a different unit, degrees Fahrenheit. So this is just one example. So if I know that, then I can figure out a bunch of things. I can also use it to create a graph. So even more useful than graphs, having a formula or an equation that relates to variables helps you to figure out exact values. So let's say, for instance, I wanted to know what the degrees Fahrenheit were, okay, when I know that my degrees Celsius are, I'm going to say, for instance, let's say 12.5 degrees Celsius, right? So I'm going to go about that using the same method as I did in the previous question. I want to know what my degrees Fahrenheit are, so I'm going to replace the C with the value that I know in degrees Celsius, so 12.5 degrees Celsius plus 32. Oops, 32. And then I'm going to solve that. So 1.8 times 12.5 plus 32. So that gives me 54.5 degrees Celsius. Now I can also use the equation on the flip side of that to figure out for an unknown. So let's say instead that they didn't give me the degrees Celsius, they wanted me to find out something in degrees Celsius, right? So let's say my degrees Celsius was my unknown, and they told me that the temperature in degrees Fahrenheit was, let's say, 80, right? 80 degrees Fahrenheit. So now I have a flipped situation. Now I can't just switch my F and my C in the equation. The equation has to stay exactly as it is. But I'm going to substitute in this 80 wherever I see the F in the equation. That's what I need to do. So I'm going to go ahead and do that. And so I'm going to rewrite this as 80 equals 1.8 C plus 32. So this may remind you of our algebra unit. This is why learning algebra is so important. I'm going to remind you of some basics from the algebra unit that will hopefully help you to solve this. So you'll remember that when solving an algebraic equation, that means getting the variable that I don't know that I want to find out about all by itself on one side of the equation. So that means that what I need to do is I need to get rid of whatever's furthest away from that variable. In this case, it's the plus 32. So whatever I do to one side, I have to do to the other. And in order to undo my adding 32, I need to subtract it on the other side. So I'm going to clean this up and rewrite this as 80 minus 32. And then that leaves me with 1.8C. And that's going to leave me at 80 minus 30 is 50, minus 2 more leaves me at 48. And that's equal to 1.8 times C. Now I still need to get C by itself, so I need to undo the fact that it's being multiplied by 1.8. Okay, the opposite of multiplying is dividing. Whatever I do to one side, I do to the other. And when I solve for that, 48 divided by 1.8 gives me the value for C as 26.66. I'm going to round that to the nearest whole degree, 27 degrees Celsius. So what that tells me is, and this is the important part, that 80 degrees Fahrenheit is equal to 27 degrees Celsius. let's take a look at a second example using an equation. So when I look at this, the first thing I want to do is to read it out, and I need to read it out as many times as I understand, right? So I'm going to start with reading out the starting portion of it. So it says a cell phone plan charges according to the following formula. It says C equals 30 plus 20.25 N. And so right now I don't know what the C and the N are representing, so I'm going to read on. It says where C represents the monthly cost in dollars. So I'm going to go ahead and I'm going to write over here cost. And then it says and N is the number of long distance minutes. So my N in this case represents the number of minutes. So I'm going to write that in because that will help to remind me what my variables are representing. So part A is asking me to create a table of values to represent the cost, and it's saying for 0, 5, and 10 long distance minutes. So you don't really need to do anything fancy to get a table of values. All you need to do really is just create a T-chart. I'm going to push this over just a little bit. Create a T-chart. And I want to know my cost at different number of minutes. And we used an N for that. So I want to find out the cost at 0, 5, and 10 minutes of long distance. Right? So remember, my cost is equal to 30 plus 0.25 times the number of minutes. So all I need to do to figure out at each of the different number of minutes what the cost is. So 30 plus 0.25 times 0, because in this first instance I'm looking at 0 minutes. And so that's going to give me 30 plus 0.25 times 0 will be 0, so this will be knocked out. So that tells me that the cost after 0 minutes is just simply $30. So I'm going to continue that process. But instead this time I'm going to look at not having 0, but having the 5 in there, because that's the next value that I want in terms of minutes. So instead I'm going to put 5 minutes. So 5 times 0.25, you need to use a calculator, totally fine. That gives me 1.25. So this little bit right here gives me 1.25. So adding that into 30, that gives me 31.25. So I'm going to put that in here, 31.25. And then after another 5 minutes, I'm going to have another 1.25 added in. So that's going to give me, let me show you that. Cost is going to be 30 plus 0.25 times 10. 0.25 times 10 will give me $2.50 plus $30 will give me exactly $22.50. Okay, so let me rewrite that just a little bit more neatly here. And so now I have all the information that I need to create a graph. So now I'm ready to create a graph. So I want to label my axes, but I don't want to use C and N. I want to actually use the label. So this was the number of minutes and cost in dollars. All right, so I want to create a graph that allows all of my values to come in, and I don't have a whole lot of values here. So I'm going to start with 0 on my x-axis. I might go 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. So here's my 10 minutes, right? So it looks, I want to create maybe a break in my graph here, and so I'm going to start maybe at exactly at 30, and then maybe go up 30, maybe by 25 cents, right? So 25, 50, 75, 31, 31.25, 31.50, 75, 32, and then 32.25, 32.50. So that'll allow me to plot all of my data on here. So at 0, I'm at 30. At 5, I'm at 31.25, so 31.25. And then at 10 minutes, I'm at 32.50, which is all the way up here. I can tell that I've done the math right in my table of values because I actually end up with a nice straight line. All right, so the next part of this question says, use your equation to determine the cost of 28 long-distance minutes. Okay, notice that I bolded use your equation. I saw this time and time again on the EQAO exam. And so it's important for you to pay attention to when they ask you to use the equation that you actually use the equation. So the cost is equal to, it gave us that it's 30 plus 0.25 n. All right, and so, you know, I know that the number of minutes happens to be 28 in this question, and they want me to figure out the cost. That's what I don't know. So I'm going to plug in this 28 minutes for the number of minutes that I have here. So I have 30 plus 0.25 times 28. I'm going to use my calculator. That's more realistic than even 10 minutes, you know, if you're making lots of phone calls. So 0.25 times 28 plus 30 gives me 37 bucks, right? So now my cost is 37. So therefore, the cost for my plan is $37. Okay, another question. This one is a little bit trickier. And I know that there are ways without using the equation that you can figure out the number of long distance minutes. But the question is stressing that you use the equation, so I want to make sure that you know how to do that. So remember our equation, the cost is equal to $30 plus 0.25 times the number of minutes. And so in this case, they're telling me my cost instead. They're saying that the bill was actually $42.40. So $42.40, right? And so this person wants to know, well, how many minutes did I actually use? Is that accurate? Is my bill right? I don't know. So I want to find out the number of minutes. So I'm going to plug in $42.40 where it belongs in the equation, where the C is. And so I have $42.40. I'm going to write that as 42.40. And then I have 30 plus 0.25 n. So now this becomes an algebraic equation that I need to solve. Right? So there's my n all by, that I want to get by itself. And it means that I need to move whatever's furthest away from the variable, but on the same side of the equation. So here's my 30. Since this 30 right here is positive, I'm going to move it to the other side, and I'm going to do the opposite of adding. I'm going to subtract it. So 42.40 minus 30 gives me positive 0.25 n. And so let me clean that up. 42.40 minus 30 will give me 12.40, 0.25 n. And now, in order to get my n all by itself, what I need to do is I need to divide by 0.25. Why am I doing that? Because I'm multiplying n by 0.25. So to undo that multiplication, I need to divide, do the opposite operation. Whatever I do to one side, I do to the other. So that will cancel out my 0.25s. I'm going to pull out my calculator, 12.40 divided by 0.25. So when I do that, I get that my value for n happens to be 49.9 charging me parts of a minute, right? What is going on here? So it's important to understand what our values represent when we're solving so that we can make sense of them. So in this case, I would be calling my phone company and saying, what's going on? All right, so those are some examples of how we might use the equation to either create a graph or to solve problems. So be sure to touch base with me if you have any questions with this. Your homework for this section is found in 7.2 in your workbook.